Hi, my name is Sigurdur Samuelsson, and I'd like to present the results of an elicitation study examining how software developers would express commands in a software development environment by sketching right on top of the IDE. Sketches, that is, informal ad hoc drawings, are a common way for engineers to express complex ideas. They are often created spontaneously with low cognitive effort to quickly express a vision of a solution while completing a larger task. Given that sketching is one of the most common ways for software developers to express their ideas, we were wondering why it is not used at all in one of their most central tools, the Software Development Environment, or IDE. Wouldn't it be convenient to express operations such as refactoring code by sketching them right on top of the IDE, much like annotating a document, as shown in the picture? Exploring this vision is the long-term driver of our research. Could sketching be a viable, effective auxiliary command modality for software tools? For an initial exploration of the potential of this vision, we examined two research questions. First, do different software engineers use sketching in similar ways to express commands? That is, do users intuitively gravitate to common approaches for sketching commands at all? And if so, what are their preferred ways of expressing common commands? The results should tell us if our vision is worth pursuing at all, and inform our follow-up research with insights into actual user expectation rather than just our own assumption of how this modality could work. To answer our research question, we performed an elicitation study with 19 participants recruited from the Icelandic software industry. Participants were shown screenshots of an IDE on a pen-enabled laptop and asked to imagine that this IDE could interpret sketches and execute the commands that they described. They were then asked how they would express 16 common operations by sketching, involving some code editing, refactoring, formatting, and code comprehension tasks. In order to answer research question number 1, that is, to determine if different developers use sketching in similar ways to express certain tasks, we calculated agreement rates for our prompts based on the method of Oberg et al. To determine if sketches agreed, we classified them by the style in which the participant had expressed commands, parameters, and selections. The detailed definition of the taxonomy and the observed breakdown of responses can be found in our paper. As a brief example, consider the 3 following responses to prompt number 3, which asked participants to move a method to a different line. Participant number 5 and 13 used a graphical approach for selecting the code block to be moved and its destination. While the visual expression are somewhat different on a stroke level, they use similar shapes for similar purposes. They are enclosing the block to be moved and pointing to the destination with an arrow. These sketches are therefore classified identically in our taxonomy, and the participant responses are considered to be in agreement. In contrast, participant number 2 defined the scope of the selection with a sidebar and expressed the command and destination with a parameter textually. This response does not agree with the other 2. Following this approach, we classified all responses and calculated the agreement rate for all the prompts. The horizontal bar chart on the left shows the results. A high agreement rate, as for prompt number 14, occurs when we observe a low number of classification groups, and there is preferably only one dominant group, that is, one group of responses that are classified identically. For example, as the stacked bar chart on the right shows, the responses for prompt number 14 fell into 3 groups, one of which contained 17 out of 19 responses. Based on these results, we can answer research question 1 positively. For 10 out of our 15 prompts, at least half of the participants sketched the envisioned command in similar ways. Looking at the responses for the dominant groups of these prompts also helps us answer research question number 2, that is, what are the preferred ways of expressing these commands? In our paper, we discussed most common sketch expressions for all prompts. I'll just show 3 here for the sake of brevity. To move a code block, most participants encircled the code to move and then drew an arrow from the enclosure to the destination line. To add a comment, most participants drew a line to the desired insertion point and then prefixed the textual comment with a symbol such as the /. To rename a variable, most participants struck through the variable and wrote out the new name next to it. Not all prompts yielded such straightforward responses, though. Participants were struggling with more complex or abstract operations, as the following example shows. Prompt number 9 asked the participants to sketch a command instructing the IDE to trace the source of a variable, that is, to show the code location where the variable is defined. We observed a couple of interesting approaches. For this example, there is one participant who drew a magnifying glass icon inspecting the variable, Another participant drew a question mark on top of the variable name. However, many participants had a difficult time coming up with an appropriate sketch response, and several suggested making long press gestures with a pen, saying they wanted a context menu to appear where they could select a command from a list. Our observation in this and similar prompts suggests that users may have an easier time sketching a command if everything that is affected by the command is visible on screen and can therefore be involved in the sketch, as was the case with the previous examples. However, if a command involves some off-screen elements, users may have a harder time expressing it in a sketch since they can't visually refer to some of its elements. Although there may be some ways of expressing such commands through sketches, they don't seem to be as intuitive. We discussed the implications of these prompts and that do not yield such clear sketch expressions in the paper, and they give rise to a number of speculations that are worth examining more closely in future studies. In conclusion, we found answers to both our research questions. First, we found that 2/3 of our prompts, at least half of the participants, sketched visually similar commands. This outcome is encouraging, as it shows that sketching is a modality in which some users intuitively express their intentions in similar ways, at least for some of the types of commands. Second, the high and the low agreement sketch expressions that we observed can serve as a starting point for further research on the human and technical aspects of sketch-based interaction, such as designing a visual common language, developing sketch interpreters, and conducting more in-depth user studies. Thanks a lot for your attention, and I'm looking forward to your questions.